Final recording, as I mentioned during the class time, we did not get the opportunity to go over the final topic of the binary search tree. So what I'm going to do with this short video recording, I will go over. Um, if you've seen and then checked lately, the Brightspace topics of the final exam are posted. Final exam is scheduled for tomorrow at noon time, reminding everyone the class time is different from the final exam time. The exam starts at 12 p.m. noon time, ends at 2 p.m. 2-hour exam, 120 minutes. Please focus on the study guide of the final exam. At the same time, focus on the final exam topics. They're all posted in Brightspace. This particular video is mainly focused on section 8.3, which is the final section of the semester. And then let's go ahead and then let me share. So I'm going to go ahead and share the screen as I'm transitioning to section 8.3. By the way, these lecture notes, additional lecture notes of 8.3 have been posted for quite some time in Brightspace. So what's the focus of this section? It's focused on the binary search tree known as the BST traversal. What is a traversal? The process of moving through all of the content of the binary search tree, and then of course listing them one by one is called the traversal process. There's a lot of information for the traversal, but this particular section and then this remaining topic for us is mainly focused on the three different efficient ways of moving through the entire content of the tree. When I say the entire content, means from one node to the other with minimal waste movement. So this is what we refer to as the efficient way of moving to every single node of the tree very efficiently. Now, each method produces a different order, and the orders that we are relying on are known as three efficient orders. One of them is the pre-order. I will be very detailed in the pre-order, and then I will go over and then move through the entire binary search tree in the other examples representing the in-order and the post-order, but not as very details as the pre-order. Feel free to look at these additional notes, but I will try my best to explain it. Hopefully this will be understandable. This is also included in the final exam focus topic. So be very careful, try to watch the video, and then try to work on this example as you watch the video to get an understanding of the process known as the traversal process, a very efficient way of moving through the knots, the entire content or the knots of the tree efficiently with the minimal waste movements. Now, what is this pre-order traversal? Now, the idea of the pre-order traversal uses a strategy that is called the pre-order strategy. We define, by the way, as I was doing this additional notes, there are a few T's that I'm missing. One of them is missing to the word parents, so I apologize for that. Parent with a T at the end, but I know there's maybe one or two others where I accidentally missed a T for the word left and then missed a T maybe for the word right. So I apologize for my grammar error done accidentally. So let's go back to the pre-order traversal. The pre-order traversals requires that the parent to come first. So the parent comes before the children, but the way you move then from the parent, you go to the left child, which is going to require to go through the entire left subtree, the left subtree branch, and then transition to the right child and then entirely to the left, to the right subtree. But as you're moving, you have to continue focus on this order. So once you go from one node to the other, or from one label to the other, you're still applying the same order. So we write letter P for parent, letter L for the left child, and then uppercase letter letter R for the right child. Sorry about that. So therefore, the pre-order strategy using parent left child or right child is going to look like PLR. But we do not operate with PLR. These are binary search tree. We prefer to operate with the lowercases, which represents the nodes of the binary search tree. So parent is called A, lowercase a, left child, lowercase b, right child, lowercase c. So that means the pre-order traversal, that means now we are in the process of moving through the knots of the binary tree, the preorder traversal is going to be A, which is parent, B, which is the left child, to C, which is the right child. So let's try to use this order in one example. Perform the preorder traversal. This is how the example is going to look like. So perform the preorder traversal of the binary tree below. So this is the binary tree below. You see some circling that identifies the left branch or the left subtree and then the right one. But at the same time, you see parent A, you see the left child B and the right child C. Now remember, this order is going to be reapplied anytime we move from one label to the other. So we start with the root, which is A, and we record the root because the reason why we're recording, because the pre-order requires to start with a parent. So record parent A, and then now we are moving to the left child. And then the idea is once we finish with the left branch, we have to transition to the right one. So after recording A, so you see A is circled. Now, as I said, this process, very detailed, is going to be applied only for one example related to the pre-order. I'm not going to do the same thing for the other ones, even though I will explain them, but not in very detail. In the final exam, it is required to really go through this very detailed, the way I'm doing the pre-order in this example. Okay, so we record A. And then from A, we have to move to the left child. So the entire left branch is circled. Once I move to the child B, then I have to finish the entire branch following the order P, L, R, but now the parent becomes B. So that means automatically I have to record B as a parent. Now from B, I have to move to the left child, which is D. And then I have to move to the right child, which is E. So that finished this level of the branch. So this level of the left branch, the left subtree. So I so far recorded A, B, D, E. Then I move to the next one, which will be my right child of the parent D. Okay, so the right child of the parent D, which is E. So if I apply, so you see, I missed the T in the word right, as I mentioned. So start PLR again. So record parent B, then move to the left child D. Okay. Now you cannot go to E because E is the right child of B without finalizing this left branch that is circled. So after recording B, I have to go to D and finalize this left branch. So I go to G, that's all final, and then I transition to the right child E. So if I record it, this is going to be A, B, D, G, E. And that finalizes my entire left subtree. Now from the left, I have to transition to the right. So you see A, B, C, D, G, E. From the left, then I have to transition to the right. I'm still with the original subtree right there. So we just finished. So the way we went, we started with A, we transitioned to B. I cannot go to C because I have to finish the entire branch. So B becomes a parent. I go to the left child D. I have to finish this branch of D. So I go to the right child. This one has, D has only one right child, G. And then once I finish this side, this left side of B, I transition to the right side of B, which is E. So I got A, B, D, G, E. And then I'm ready to move to the left subtree. So left subtree is going to be child, parent C, and then child E to the left. There is no child to the right. So what is my final order after going through this? A, B, D, G, E, C, and F. And that finalizes the pre-order using PLR. PLR strategy, or ABC, stands for parent, left child, right child. Now let's transition into the next order, which is the in order. As I said, I'm not going to be very detailed, but I will explain how this is going to change. The in order traversal requires to start with the left child, then go to the parent, then go to the right. So P for the parent, which is the knot A, L for the left child, which is the knot B, R for the right child, which is the knot C. So we start with left. So we're going to start with B and then transition to parent A and then to the right C. So the in-order strategy is LPR. I'm missing an R in the word strategy. So I apologize for this grammar error. And the in-order traversal, there's no N in the word traversal. That's another mistake. Traversal without an N. It's BAC. Once again, I apologize for all my grammar error. Here's the correct word, traversal. So perform the in-order traversal for the binary tree below, same binary tree. So we start LPR, so it's not PLR, it's LPR. So that means we start with B. Now, as we start with B, we have to move through the entire rooted to the entire subtree that is rooted at B. Then once we finish this left subtree, then we have to go to parent A and then transition to the subtree rooted at C. So here's the in order final list is D, B, then G, then E, then you go to A, then F and C. Now I have to explain this. So you know that you cannot start at A. So we start at B. This is a parent for this entire subtree. And then we have to run through the entire left subtree that is rooted at B. So the root is B. Now, I cannot record B because remember it's left, parent, right. So I have to record D. If this is the parent B, so I have to record D first. Then I go to the parent B. How come I cannot go to G? Because this is to the right. So I go to the parent B, but I still have to finish. So after going to the parent, I have to go to G, which is the right child of D. And then I go to the right child of B. So the right child of D comes before the right child of the B, because the way we start is starting with the left child. So left, you cannot go to G, you have to go to the parent, then finish G, which is the right of D, then finish E, which is the right of B. So it's D, B, G, E, and then transition to the parent A, which is the original one, and then transition to the right subtree rooted at C. Now, once I go to A, remember, this is subtree rooted at C. C is a parent now, rooted C, right, for the subtree. So you have to start with the left child, which is F. So after A, we have F, then C. That's why you get DBG, E, A, F, C. And then the final is the post-order traversal. This one is parent comes after children. So we start with the left child. We start with the left child. We transition to or traverse to the right, then to the parent P. So the post-order strategy is going to be LPR. Also, the post-order traversal is going to be BCA. So LRP or BCA. So let's see an example. Remember the order. Perform the post-order traversal of the binary tree below. So we start with B. And then we go through the entire branch, which is to the left, that is rooted at B. Now, remember, B is the parent, right? So we cannot start with parent. We have to start with the left child, and then transition to the right, then transition to the parent. So start with the left subtree, rooted at B, and finish the entire subtree, rooted at B. Then move to the subtree, rooted at C, and finish up. Then go back to the parent A. And that's what I'm going to do. So this is the left subtree. I kind of like split it up for you to see it. So rooted at B. I start with the left, which is D. And then I go, remember in the previous case, the in order, I had to go to the parent. Now, in this post order, I have to go to the right child. And then D has a right child. So I go from D to G, which is the right child. Then I transition to the right child of B. I cannot go to B. Remember, it's left child, right child, then parent. So this is the entire branch rooted at B. So I record B, which is the left child of the root B. And then from the left, I go to the right child of it, which is G, and to the right child of B, which is E. Then I go to the parent B. So that's going to finalize the entire left subtree rooted at B. Now, from this left, you have to go to the right. We start with F, which is the left child of the root C. And there's no right, so we have to go from F to C. And finally, we go to A. So the solution is DGE BFCA. So I hope you find this very useful. Try to work it and then try to watch the video and then go through the example on your own to better understand it. Good luck tomorrow. I'll see everyone tomorrow. Bye-bye.